Welcome back. This is the second lesson recording for IM1, September 22nd, 2020. So I started talking about this being a new grading cycle. So I am going to start over again. Okay, so basically we are studying a grading cycle 2. And the way you're going to be successful in this class is if you have motivation plus mathematical skills. That's going to lead you to successful in IM1. When we say success, we're really talking about C minus or better, because if you're getting less than C minus, if you're getting a D, even though you might be getting credit for high school graduation, I am not going to be recommending you to move on to IM2. Why? Because you do not have the skills that is necessary for you to be successful in IM2. You're basically not ready for IM2. Okay, so I am not all about grades. However, it is a reflection of how well you know your IM1. So, few problems, those people who are not getting C minus or better. Few problem is that you are not motivated to do well. Okay, so that starts off being not paying attention during the class meeting. Like I have said to my classroom, I cannot force you to learn. You can be present during Zoom class, and that should be a priority. But if you are choosing to not to participate, you're choosing to not to do the work, you're choosing to play video games on the side or chat with your friends, go on the social media or watch some YouTube movie, whatever else, I cannot do anything for you because you're doing something else. You're not paying attention. However, if that is the case, then you're going to have difficulty completing the homework correctly. It's not just doing the homework, but doing it correctly so that you are processing the learning that is we're doing in class. And if you're not doing the homework correctly, then you're going to have difficulty processing the next class meeting. It's going to start to sort of sound a little bit more like a foreign language class. Why? Because we're going to use terms, we're going to use some skills that you should have mastered from doing the previous homework. And then it's going to become a little bit more boring for you because you don't understand what's going on. And it's going to be a little bit more nerve-wracking, or you're going to start to feel a little bit more of anxiety because you don't want other people to find out that you do not know how to do the math. Then you're not going to be paying attention, and it's a vicious cycle. Then you're going to continue to not do the homework correctly or not do the homework at all. And eventually, by the end of the unit, you're going to be so lost that you are not going to understand what's going on in the class at all, as well as you're going to do poorly on the quizzes and tests, and ultimately, you're not going to be successful in IM1. However, it's not too late to develop better study habits. So it's not too late for you to turn yourself around. If you keep doing the same thing you've been doing, you're probably going to get the same thing you've been getting, right? That's just life. So start making some changes. Some of you are lacking skills. So maybe the foundational math that you should have learned in middle school or previous years, you have some holes in that. If that is you, then you should be paying attention during class, and you should definitely be coming to study hall session at 2:15 p.m. on the B days, not A days, to do the homework correctly. Hopefully we'll be able to backfill some of the holes in the foundational math skills that you might have. Okay, again, it is not too late to develop better study skills right now so that you can pass, not only pass, but be successful in IM1 and the math classes beyond. Okay, so let me just quickly go on some of the problems that some students got wrong on the test. The function notation. The question asks, what does the notation g of x mean? How does it relate to a function? How do you read this notation? What I was looking for was that input was x and the g of x is the output. And there's a rule here. So g is the name of the function, and the rule of the function is going to be what is identified as g of x, and the g of x is also the output when the input is x, and the x represents the input of the function. And it is read as g of x. So that would have given you all the points that you needed. Okay? Some of you said this is how you write multiplying g by x. No, no, no. That is not the case at all. This is the one situation where g parenthesis x does not mean multiplication. So you need to be clear on that. Okay? And the other problem was Solution or not. Rowan said the solution to the equation 12 over x is equal to 48 is 4. Do you agree or disagree? And you had to explain. Well, this equation is not true, so solution is not 4. Okay, so solution has to make the equation true. So if that means if I plug in 4, is the equation true? If I divide 12, divide by 4, is that equal to 48? No, it is not, right? So this is not a solution. Okay, and that's what I needed to hear from you. Okay, let's move on to chapter 2 of CPM. We are going to be going into linear functions, and to do so we are going to be asking the question, how does the pattern grow? Okay, so you have these tiles here, figure 1, figure 2, and figure 3. Obviously you're getting more tiles for each figure. How is it growing? If I know the figure number, how do I find the number of tiles? And that's the question that we are going to be focusing on, as well as we are going to represent the situation. This is a situation as an equation, as a table, and as graph. That's what we're doing today. The input in this case is the figure number, and the output is the number of tiles. So if I was to talk about input, the figure number is 1. That means that x is going to be the input is going to be 1. The figure number is 2, so the x in this case is 2. X in this case is 3. Okay, and the output is the number of tiles. Number of tiles, how many tiles do I have? 1, 2, 3, 4, 5, 6, 7. So output is 7. And in this case I count 10. And in this case I count output is 13, because I have 13 tiles altogether. Okay, so this is where you went into groups, breakout rooms, and where you worked on this Google Doc. If you have a printer, you were supposed to print it out, and if you did not have a printer, you were supposed to copy figures and answer prompts. And you are working in your team to discuss, but write your own paper, because you are going to be turning it in at the end as well. Okay, so this is the work that you're turning in if you were absent and you're catching up. All right, so the Google Doc is going to be found in the Canvas, in either lesson resources or the classwork CPM group work. If you go to modules under week 7 and open up the Tuesday, September 22nd, 20 classwork CPM group work, you should be able to find the link to this Google Doc. I suggest that you do not modify the Google Doc itself, but you write the answers in your notebook. You have 20 minutes. Okay, please pause the video and work on it right now. And I am going to go through the answers together right now. Okay, so what you were supposed to do was seeing the growth in linear function. We were supposed to, A, how are the tiles changing? Well, how are the tiles changing? And where is it added? And figure 4 and figure 0. Those were the questions. If you have not done so, no point in just watching this. You need to do the work itself so that this will make sense to you. So the first thing I am going to do when I do this kind of problem is to color the previous shape. Okay, so I see 1, 2, 3, 4, 5, 6 at the bottom plus 1. So I know that this was from the previous shape. Okay, that means that the new ones that were added in figure 2 was this 3. Okay, 1 here on the left arm, 2 on the right arm. What about figure 3? Well, let's go from the figure 2 and just shade in what figure 2 was. What figure 2 was had 4 on this arm and the bottom and 2 on the left arm. Okay, and then it's really clear to see that what is new added was we added 3 to it. Okay, then we can infer that 3 was added to this figure and that this was the previous figure. So then I can say that, okay, I know from this, I know that figure 0 had 4 to begin with. Okay, and then figure 7 had, I count 7 altogether here, and figure 2 had 10, and figure 3 had 13. So this is what I would do. Okay, now can I figure out what figure 4 is? So yes, I can draw this. Oops, let me just erase this part a little bit. Okay, and I know that, let me just draw what I am starting off with from the previous one. So 1 2 3 4 5 1 2 3 4 5 6, and I have 1 2 3 4 5 6 on that arm. So I am going to draw really small so that I can fit it in. 1 2 3 1 2 3 4 5 6. Okay, so this is just the previous shape. Okay, then to this I know that 2 is going to be at 1 more is going to be added here, and 2 more is going to be added here. If I go from the previous shape and then add 2 more, this is far easier. Okay, and if I count this, I should get 17 as my total number of figures. So the next question asks you the starting value. What is the starting value? Starting value is really talking about figure 0. Okay, how many do you have to start off with? In the figure 0, you have 4. So if I am just going to show you the answer, the D starting value should be 4. Okay, and then the growth, how many is being added? We're adding 3, so growth will be 3. All right, then you represent this as a table and as a graph. So this is really saying when the input, the figure number, in this case when the figure number was 0, you had 4 tiles. This is the number of tiles. And that represents the y-axis, and the figure number is the x-axis because that's the input, x, and the y-axis is not going to be number of tiles. And this tells me when the figure number was 0, you had 4 tiles. When the figure number was 1, you had 7 tiles. When the figure number was 2, 10, and so on. And if you plot this as coordinates 0, 4, in this case, this will be 0 is x, 4. This will be this point. 1, 7 will be 1, 7 here. 1, 7 will be this point, and so on. You are plotting this, and if you join those points, you will find a straight line. Okay. All right, then F asked you, how can you calculate the 100th, how many tiles you would have in the 100th tile? Well, we don't want to keep drawing it 100 times because that will be cumbersome. But we can use our math. So from figure 0 to 100, the number of growth is 3 each time. We know that it's growing 3 tiles each figure, and so we are going to do that 100 times. So that's going to be 3 times 100 here. And we are also starting with figure 0 as 4. To that, we're going to add figure 0's number, which is 4. Okay, so this is for F. And so the answer should be 300. 3 times 100 is 300, plus 4 is 304. And then G, from figure 0 to figure X, we grow 3 tiles of figure X. If we don't know this figure number, we put that as a variable. We just know instead of 100, we are going to multiply by X times, right? So it becomes 3 times X plus 4. So the equation becomes y is equal to 3x plus 4, where y represents the number of tiles and x represents the figure number. Okay, so we are going from the figure tile growth into an equation representing it. Okay, so as closure, you are supposed to write the table of contents, today's date, and what did we do today? Simplifying exponent expressions and linear functions of tile growth. And I need you to scan and submit your simplifying exponents expression notes as well as the tile growth, the group work that you did. That's the 2.1 tile growth to today's work in Canvas under week 7. And the CPM homework is these problems that you should be able to access it from ebook. If you need help, you should be coming to see me. Okay, that's it for today. Okay, have a good one.